Good morning, students. Now we take D and F block elements. So write down D and F block elements. As you know, in 11th class we have done those elements whose last electrons enters in D subshell of an atom. So write down those elements whose last electron enters in D subshell of an atom. Those elements whose last electrons enters in D subshell of an atom is called D block elements. Is called D block elements. All transition elements are called D block, but all D block elements, all transitions are called D block, but all D block elements are not transition due to fully filled D orbital. Thus, transitions means they have incomplete filled d orbitals. That is, the capacity of d orbital is 1 to 10, but 1 to 9 are real transition, and the completely filled d orbitals, that means even they are d block elements, but they are not the real transition. They are called pseudo transition elements. So such elements are called pseudo transition elements because of due to completely filled d orbitals. For example, zinc, cadmium and mercury, 80, 48 and 30. So the configuration is the argon 3d10 4s2, krypton 36 4d10 5s2, and then xenon, so far as mercury is concerned, 4f14 5d10 and 6s2. So what is your observation? 3d10, 4d10 and 5d10 means they have completely filled the orbital, so they are known as pseudo. Pseudo means the false transition elements, right? So now we take the position of d block elements in the periodic table. Position of d block elements: scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. Group number is 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. 13 to 18 are known as, P block elements. So far as it is, these are members of the 4th period, now 5th period, 6th period and 7th period. Atrium, lanthanum and actinium, zirconium and hafnium, niobium, and tantalum, molybdenum and tungsten, Tc and Re, Ru, Rh, palladium, osmium, iridium and platinum, copper, Ag, Au, zinc, cadmium and mercury. You have to remember the name of the elements as well as position. These are very useful because of to write the electronic configurations. Dear students, these are the position of transition element. So far as fourth period, 21, 22, 23, 24, manganese 25, iron 26, cobalt 27, 28, 29 and 30, mercury, cadmium 48 and mercury is the 80, 47 and 79, 39, 57 or 89. Now zirconium is 40, 41, 42, 43, 44, 45 and palladium is 46. So here you have to take one star to remember. 7th is the length, 6 is the lanthanide series, just to the lanthanum, right? So 58 to 71 are lanthanide series, right? That is why 71. So this is the 72, 73, tungsten 74, 75, 76, 77, 78, 79 and 80. Now again you write the double star so that the 7th period is the next to the actinum. Actinide series starts from atomic number 90, right? So 90 to 103, then it is the 104, 105, 106, 107, 108, 109, 110, 111, 112. You remember in 11th class, barium, anium, nelium, nilanium, niloctium, nilseptium, nilhexium, nilpentium, nilquadium. These are expected atomic number which are discovered yet. And then just for the F block elements here, this is the 58, 59, 60, 61, 62, 63, 64, 65, 66, 67. Then you can say 68, 69, 70 and what is that? 71. CE, PR, ND, PM, SM, EU, gadolinium, TB, DY, HO, ER, TM, YB and lutetium. These are elements 14. These are lanthanide series 58 to 71, cerium to lutetium. Right, now the 7th period you are taking from next to the actinum, that is next to 89, 90, 91, then 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102 and 103. So this is the thorium, Pa, uranium, neptunium, plutonium, americium, Cm, Bk, Cf, Es, Fm, Md, NO and lawrencium. So these are again the 14 elements. So 14 plus 14, total F block elements are how much here? 28. Total F block elements, that is the lanthanide series as well as actinide series, including 14 plus 14, all are metals These are 28 elements. 6th period next to the lanthanum are lanthanide series, and 7th period just next to the actinum, actinide series that takes place from thorium 2 up to that. So dear students, you have to remember and retain the atomic number and name of all the elements, because these are the integral part of the 12th class. Am I right? So let us discuss the properties of D block elements. Here we will discuss only the conceptual part of the D block elements, not the theoretical part. Right. So main important point, important properties usually come in the CBSE final paper, that area where we have selected to discuss for you. Now the important properties of D and what block? F block. First we take very important outer electronic configuration. You remember, first you write the inert gas n-1 D 1 to 10 ns 0 to 2. All cases S is 2, but so far as exceptional case is concerned, that is maybe 0, 1 or 2. And then n is the number of periods, n is the number of periods. N starts from, this is the 4th period, right? That can be the 5th, 6th and so far as the 7th period. So you can create the formula, and here it is the n, here 4 minus 1 3D, and this is the 4s. D capacity right from 1 to 10. So first we take, outer electronic configuration of first transition series. We take outer electronic configuration of first transition series, very much known as 3D series. Why they are known as 3D series? Because they have 3D subshell in outermost orbit. That is why scandium to titanium, vanadium up to the zinc known as 3D series or the first transition series. Right. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. You remember 30, 29, 28, 27, 26, 25, 24, 23, 22 and 21. This is the argon. That is what? In all cases we have to write argon, because scandium 21 is close to the argon. So you put the argon, everywhere you write the argon. Here it is the argon, and then argon 3D, and what is that? Energy rule is 3D 4s, 3D 4s and 3D, what is that? 4s. So write here 3D and what is that? 4s, 3D 4s, 3D 4s, 3D 4s, 3D 4s, 3D and 4s. So here scandium, that is the 4s2 or 3D 1. 2 plus 1, 3 plus 18, that is 21. So you go to increase cumulative increase in the atomic number electrons in the d subshell, 2 and 2, 2 and 3, and this is the chromium. You remember exceptional case, half filled orbital, you remember it in 11th class. So this is the 5 2, 6 2, 7 2, 8 2, copper is 10 1, it is the 10 2. Just to go for scandium to zinc, 3D series, 3D, 3D, 3D. So it is the first transition series. The way you can write the configuration of the second transition series, that's the 4D series. But some important exceptional case we have to remember. Right. So you take the B part here. This is the B part. Outer electronic configuration of second transition series, and that is the 4D series, right? In case of that, that is the 39, 40, 41, 42, 43, 44, 45, 46. So 47, 45, 46, 47, and then you can say 48. See, just you have to go for that. 39, 40, 41, that is the 42, 43, 44, 45, 46, 47, and what is that? 48. So here you remember, this is the yttrium, zirconium, and then 48 is the cadmium, 47 silver, 45 palladium. The way you have to go for, what is that? And this is the 3D, and then what is that? 4D series. So the configuration is like this is the 39 is the krypton, 36 and 4D and 5s. The way you have to arrange all the formula, that is so you have to remember the strengths you have to go through. Krypton, further write krypton, or and the krypton. 4D, and what is that? 4D 5s, 4D 5s, 4D 5s, 4D and 5s, 4D 5s, 4D 5s, 4D 5s, 4D 5s, and the last is the 4D, and what is that? 5s. So just to go for, this is what it is, the that is the yttrium, zirconium, niobium, molybdenum, zirconium, and then niobium, what is that? Molybdenum, and then technetium, TCRURH, the way you can go for the electronic configuration, that is the 2 and 1, 2 and 2, then go for the exceptional 2 and 4, 1 and 4, 1 and 5, 1 and 6, 1 and 7, 1 and 8. So far as palladium is concerned, highly exceptional. You have to remember it. 4D10, very very important, not only for the academics but the entrance classes also. Then 4D10 5s0, 4D10 5s1, and 4D10 5s2. Just to go for, and then you write the configuration 4D, 4D and 4D, and that is the 5s2, and then these are the exceptional, and here the discussion for the exceptional is beyond your scope. You will study in higher classes. Here only you have to remember whose elements are exceptional in nature. Right. The last configurational formula is, that is what? Outer electronic configuration of third transition series. Outer electronic configuration of third, 4D series. Right. So the 4D series starts from, what is that? Just for lanthanum. And you remember, this is the lanthanum 57, and you remove 58 to 71. Why you have to remove? Because these are what block? F block, and then 71 के बाद 72, 73, 74, 75, 76, 77, 78, 79 and 80. You know 80 is the mercury, 79 is the gold, 78 is the platinum, iridium, and then 76 right now. So HFTAW, and 75 is the, you can see ReOSIR, osmium and iridium, platinum and gold and mercury is like that. So we just go for, first of all you write the xenon 4F, 5D and 6S. These are the configuration, right? These are the F block elements. And again you take the help of xenon 4F, 5D and 6S, 4F, 5D and 6S, 4F, 5D and 6S, 4F, 5D and 6S. You have to repeat it. 4F, 5D and 6S, 4F, 5D and 6S, 4F, 5D and 6S, 4F, 5D and 6S, 4F, 5D and what is that? 6S. This is the 2, 1 or it is the 0. 2 plus 1, 3 plus 54. This is the 57. Then 4F, 14, 14, 14. Because of F orbitals are completely filled. Here, this is the 2 and 2. 2 plus 2, 4. 4 plus 14, 18. 18 plus 54, 72. 2 and 3. This is the 4, 5. Now, this is the 6, 7, 8. And then platinum is, what is that? You have to write important, 59, 6S1. It is the exceptional case, 5D10, 6S1 or 5D10, 6S2. So we have to remember platinum is such a case. It will be helpful in coordination chemistry to remember all these. So dear students, there we have explained actually the outer electronic configuration of first transition series, second transition series and third transition series. That is what 3D series, 4D series and 5D series.